In this experiment, we're going to demonstrate a nucleophilic substitution reaction using the synthesis of saccharin. So we're going to measure 2.1 grams of sodium saccharin, which is around 2.1 grams, and we're going to add to a Erlenmeyer flask. In addition to the saccharin, the sodium saccharin, we're going to add about 5 ml of NN dimethyl formamide. We're going to slightly stir the solution to start dissolving a little bit. And we're going to place in a hot water bath of about 80 degrees Celsius for about 3 minutes until it gets fully dissolved.
I want to see. Now we're trying to show you how to yeah, stronger stuff. Stronger than 1%? Right here.
So it's now fully dissolved, so we're going to leave it in the hot water bath for a few more minutes until it's fully dissolved. So now that it has fully dissolved, we're going to remove from the water bath, from the hot water bath.
That's not he's like, that doesn't work. I'm like, try it. I was like,
We're going to measure about 0.8 ml of iodoethane, and we're going to add that to our solution.
yeah, but I'm Alright, ready? 1, 2, 3, go. They're just like, ha ha ha. He tried all sorts of things. Yeah, my friend's like, oh, let's see what happens. Just like bear hugs, and he's like 6'7", he's like huge, and I was just like, and I died.
This is flammable, so we want to make sure it stays in the hood. We're going to swirl a little bit, and we're going to put back in the hot water bath for about 10 more minutes. So now I'm going to do... So 10 minutes have passed, and the solution went from clear to yellow. We're going to remove from the hot water bath, and we're going to let it cool down to room temperature for a while before we continue. So it feels like the solution has cooled down to room temperature, and the next step is 40 ml of cold water, and we're going to add that to the flask.
Right here, these are the ones that could possibly be that have the same.
Did we do the experiment wrong?
So this one is a colorless.
That was done.
This is obviously not colorless.
So there was a reaction there, formation of white precipitate immediately, and you get a little bit warmer as well. So we're going to place the flask in ice water bath for about 10 minutes to bring down the temperature. And then we're going to add the weight just to keep it from tilting over. So stay there for 10 minutes. We're halfway there. It's been about 5 minutes, and it's already noticeable the formation of the yellow precipitate due to the lower temperature. So we have 5 more minutes to go, and we should see the formation of more precipitate. So 10 minutes have passed, and now we have our precipitate, and we're going to proceed
So we're going to separate the precipitate from the supernatant through vacuum filtration. So we're going to go ahead and pour this in. Making sure that the vacuum filtration system is on. And then Anna is going to add some water so that we can get the rest of the precipitate
We
out.
want to collect as much precipitate as possible. So we're going to use 10 mLs, about 10 mLs of water, and try to get all the solid out of it.
Actually, it's my friend's last name.
You will not dissolve. It will stay there. So we just want to really scrape the walls of the flask to get the most yield possible.
Alright, you guys ready? Ready? 1, 2, 3. 1 nitrogen divided by 2.
They would have to like say something different about it, like pepper than you. Yeah.
I'm going to scrape a little bit more. Every little bit counts. So we just want to make sure it's dry, and I'm going to crush it, the precipitate a little bit. That is our saccharin. It's an artificial sweetener, so it's a sweet experiment. And we just want to make sure that we try to drive all the water out by this vacuum filtration. So when this is submitted to the NMR analysis, we can have a good NMR. So once vacuum filtration has completed, we determine that the product is dry enough to be transferred to a separate container. So we're going to try to scrape as much as possible out of the funnel. And you can notice a strong smell. Almost smells a little bitter, but this is actually really sweet. Much more sweet than table sugar. This is also known to be carcinogenic, so there are controversies about this chemical.
So you want to do it all over again? We don't know what it is. Alright, so do we do it all over again?
Yeah, what happened? Keep the same.
Who wants it? Do the same thing. That's
You
not
don't
right.
Don't dump it.
This looks like a very good yield. The product most likely to be abundant in this reaction is N O-ethylsaccharin, as it is more stable thermodynamically than O-ethylsaccharin. Although kinetically, O-ethylsaccharin is more stable because of the electronegativity of the oxygen in the formula. In this case, you would react faster at lower temperatures. But the proton NMR can be used to determine the composition of this product by analyzing the de-shielding effect from the protons on the oxygen and nitrogen atom and their chemical shifts.